In August of 2025, the ground beneath Northern California began to vibrate, not with a single seismic jolt, but with a persistent, unnerving tremor. Over 2 weeks, more than 500 earthquakes rattled the base of a silent, snow-covered giant. This wasn't the San Andreas Fault waking up. This was something different. Something ancient. California's colossal, sleeping volcano, Mount Shasta, was stirring. And it was doing something it hadn't done in 200 years. The United States Geological Survey ranks Mount Shasta as the 5th most dangerous volcano in the nation, not for what it did recently, but for what it is capable of doing tomorrow. And if this swarm of earthquakes signals what scientists quietly fear, the beautiful, postcard-perfect mountain that dominates California's northern skyline is about to remind everyone what it truly is, a very high-threat geological time bomb. What you are about to see is not a worst-case scenario. It is a chronicle of what has already happened, and what the evidence says will happen again. Because the most unsettling part isn't that a supervolcano is waking up in America's most populated state. It is that the last time it cleared its throat, no one was here to see it. Today, millions are. If you've ever looked at this mountain in wonder, what you learn today might change that to fear. So, comment below with the one question you have about this sleeping giant. What do you want to know most? Now, a lot of people find these deep dives fascinating, but a huge number of you watch and just forget to subscribe. Hitting that button is the #1 signal you can send that these investigations are something you want more of. Our channel's survival genuinely depends on it. If you find this important, it's an emergency for us that you click that button. It takes 1 second, and it means everything. All right, let's begin. Mount Shasta was never supposed to be this quiet. By every geological measure, this mountain is an anomaly. It stands 14,179 feet tall, the 5th highest peak in California, a landmark visible for 100 miles in every direction. But its height is a distraction. The real story is its volume. An almost incomprehensible 85 cubic miles of rock, ash, and solidified magma. That is more material than Mount St. Helens, Mount Hood, and Mount Rainier combined, by some calculations. It's a mass so enormous it has created its own weather systems, its own ecosystems, its own gravitational presence in the landscape. It is not a mountain. It is a monument to past cataclysms. This was never a place where a single, simple volcano was meant to exist. Shasta is a composite. A Frankenstein's monster of volcanic architecture, built from the remains of at least 4 other volcanoes that have grown and collapsed on top of each other over 500,000 years. There is the ancient Sargent's Ridge, the weathered Misery Hill, the prominent satellite cone of Shastina on its western flank, and the youngest, highest, and most active of them all, Hotlum Cone. This is the peak within the peak. The cone that formed just 8,000 years ago, and is the source of the mountain's most recent unrest. Each cone is a chapter in a very violent history book, a history of building and then coming apart. The most common misconception about Shasta is that it is extinct, a beautiful, dead piece of geology. This is dangerously wrong. The mountain is alive. And it is breathing. High on its summit, just 200 feet below the peak, lies an area called Sulphur Springs. Here, the ground is warm to the touch. Fumaroles, vents in the Earth's crust, hiss with a constant stream of hot, sulfurous gases that smell faintly of rotten eggs. This is not a quaint geothermal feature. This is the direct signature of a deep, active magma reservoir. It is the volcano exhaling. In 1875, the legendary naturalist John Muir was caught on the summit in a sudden, violent blizzard. Freezing, facing certain death, he and his climbing partner survived the night only by lying down in the hot mud of the Sulphur Springs, allowing the volcano's own internal heat to keep them from freezing solid. Muir survived because the mountain is burning from within. It is this internal fire that has brought us scientists back to the summit again and again. Geochemist Sarah Peak from the California Volcano Observatory, or CalVo, leads expeditions to this exact spot. Her team isn't sightseeing. They are collecting samples of these gases, bottling the volcano's breath, and taking it back to a lab. They are analyzing its chemical signature, looking for changes in the ratios of carbon dioxide to sulfur dioxide, searching for traces of helium-3. These are the telltale signs of new magma rising from deep within the Earth's mantle, pressurizing the system from below. Every sample is a data point in a long-term medical chart for a patient that has a history of violent outbursts. The gas sampling confirms a chilling reality. The deep-seated magma reservoir is not just active, it is breathing. The question Sarah Peak's work tries to answer is whether the giant is taking a deep, slow breath, or if it's hyperventilating before an eruption. The 2025 earthquake swarm suggests the latter. This kind of constant monitoring is a new development. For decades, Shasta was California's forgotten volcano, overshadowed by the state's obsession with earthquakes. But that is changing, because scientists have uncovered a secret in Shasta's past that makes its future terrifyingly clear. And it all started with a set of hills that made no sense. Think back to the most important part of this story and comment your thoughts below. What surprised you the most so far? The idea that this mountain is breathing saved John Muir's life, or the sheer volume of it? Let your thoughts be heard. For more than a century, geologists who studied the Shasta Valley, the vast plain that stretches out to the northwest of the volcano, were stumped by a bizarre feature. The landscape is dotted with hundreds of rolling hills, some small, some several hundred feet high. They called them hummocks. And for the longest time, the best theory was that they were a field of tiny, ancient, extinct volcanoes. It was a strange, but plausible, explanation for an unusual landform. Phil Dawson, the scientist in charge at CalVo, described the professional confusion best: that debris flow was recognized to be unusual from the very first time any geologist came across Northern California all the way back to the 1800s. It's just an unusual landform. Then, on May 18th, 1980, Mount St. Helens in Washington state did something no one had expected. It did not just erupt upwards. Its northern flank collapsed, unleashing a colossal sideways blast and one of the largest landslides in recorded history. In that moment of catastrophic failure, everything suddenly clicked into place for the scientists looking at Mount Shasta. The hummocks in the Shasta Valley were not small volcanoes. They were the shattered pieces of a much, much older Mount Shasta. About 300,000 years ago, an ancestral version of the volcano did exactly what St. Helens did, but on a scale that dwarfs it. The side of the mountain catastrophically failed, unleashing a 6.5 cubic mile debris avalanche, an unstoppable river of rock and earth that buried 170 square miles of the Shasta Valley. The rolling hills that baffled geologists for a century are the titanic chunks of that ancient mountain, scattered across the valley floor like rubble from a demolished skyscraper. Mount St. Helens provided the clue. Shasta provided the horrifying proof of what a truly massive lateral collapse looks like. This discovery rewrote the entire threat assessment for Mount Shasta. The danger was not just ashfall or lava flows. The danger was in the mountain's fundamental structural integrity. It has a genetic predisposition to fall apart. And because the current mountain is built on top of the rubble of its old self, it is inherently less stable. The very ground it stands on is the debris of its own past failures. The St. Helens eruption of 1980 was a wake-up call. It was a violent, destructive event that reshaped the landscape and our understanding of volcanism. But the prehistoric Shasta collapse was at least 10 times larger in volume. And it happened here, in California. The evidence is not buried in a geology textbook. You can drive through it. You can see the bones of the old mountain resting in the valley. It serves as a permanent physical reminder that these giants do not just blow their tops. Sometimes they fall to pieces. The discovery was a paradigm shift. Hazard maps were redrawn, risk models were recalibrated. The volcano was no longer just a vertical threat, it was a horizontal one. And all of this historical context makes the recent earthquake swarm so much more unsettling. Because what shakes a mountain like this apart is not just magma, it is seismic activity. The very same kind of activity that announced its return in August 2025. Before we go on, if you're finding this story as gripping as I am, take a second and hit the like button. It tells the algorithm that stories about science and geology matter. And if you have family or friends who love this kind of deep dive, share it with them. It's the kind of story that changes how you see the world around you. The ancient collapse is a ghost story, a warning from the deep past. But there is a second, more immediate threat. A danger created by a simple, powerful equation. Fire and ice. Mount Shasta holds the largest collection of glaciers in California. Whitney, Bolam, Hotlam, these are not just rivers of ice. They are a critical component of the volcano's threat profile. They represent billions of gallons of water, frozen and locked in place on the steep slopes of an active volcano. Now, imagine what happens when the internal furnace is turned up. When magma rises, or even when the geothermal system just heats up slightly, that heat doesn't have to reach the surface to cause a disaster. It just has to reach the ice. The rapid melting of these massive glaciers from below would create lahars. A lahar is not a mudslide. It is a terrifying, fast-moving slurry of meltwater, mud, volcanic ash, and boulders, with the consistency of wet concrete. They can travel at speeds exceeding 60 miles per hour, scouring river valleys clean, burying everything in their path under a thick, suffocating layer of gray cement. We don't have to imagine this. Mount Shasta has already done it. This brings us back to the 200-year timeline. While the last true magmatic eruption to breach the surface was about 30,200 years ago, that is not the last time the volcano got violent. Around the 1820s, approximately 200 years ago, something happened on the Hotlam Cone. It was not a full-blown eruption, but a localized event that produced a pyroclastic flow, a cloud of superheated gas and ash, and boiling hot lahars. These mudflows surged down the mountain's eastern flank, rushing 5 miles down Ash Creek and an astonishing 12 miles down Mud Creek. This was not an ancient event from the dawn of time. This was in the 19th century. And it proves a critical point. Mount Shasta does not need to have a catastrophic, mountain-destroying eruption to create a catastrophic, valley-destroying disaster. A small phreatic steam blast, or just a geothermal hiccup, is enough to unleash the power of the glaciers. Now, consider the modern landscape. Interstate 5, one of the most critical economic arteries on the West Coast, runs directly along the base of Mount Shasta. The towns of Weed, Mount Shasta City, and Dunsmuir lie squarely in the path of potential lahar flows from multiple drainages. A lahar triggered on Shasta's western flank could sever I-5 in minutes, not hours, with almost no warning. The communities built in the shadow of the mountain are living with a threat that last materialized 200 years ago, a blink of an eye in geologic time. This fire and ice equation is what makes Shasta so uniquely dangerous among California's volcanoes. Its massive volume and heavy ice cover mean that any sudden internal heating could trigger devastating lahars long before a full eruption even begins. The shaking from the August 2025 earthquake swarm wasn't just a sign of magma potentially on the move. It was a vibration that could, in theory, destabilize the very slopes that hold the ice in place. It's a chain reaction, waiting for a trigger. Even the massive D4 natural avalanche that ripped 3,200 vertical feet down Avalanche Gulch in February 2024 was a stark reminder of the mountain's raw physical power and instability, even when the magma is quiet. I know this is the second time I'm asking, but it's just that important. If you haven't subscribed, please consider it. I see the stats, and thousands of you who love these documentaries haven't done it yet. Think of it as casting a vote for more deep dive content. It's the single most powerful thing you can do to support this channel. Thank you. So, we have a mountain with a history of catastrophic collapse. A mountain capped with ice, burning from within, capable of unleashing unimaginable mudflows. And now, a mountain that is shaking. This brings us back to the present, to the swarm of over 500 earthquakes in August 2025. For volcanologists, an earthquake swarm is a message from the underworld. But it is a message written in a cryptic language. It could mean one of three things. First, it could be tectonic, regional stresses in the Earth's crust being released. This is the least worrisome option. Second, it could be hydrothermal, water superheated by the volcano's plumbing, moving through cracks and fissures in the rock, causing it to fracture and shudder. This is a sign of an active system, but not necessarily a prelude to an eruption. Then there is the third possibility, the one that keeps scientists at the California Volcano Observatory awake at night. The swarm could be caused by magma itself, moving and shouldering its way through the crust. As it rises, it breaks the rock ahead of it, generating a distinct pattern of small, persistent earthquakes. The critical questions are, where are these quakes happening? And are they getting shallower? If the earthquakes are migrating toward the surface, it is a primary indicator that magma is on the move, ascending towards an eventual eruption. The 2025 swarm was the strongest to hit the mountain in over 2 decades, ending a long period of relative quiet that had lasted since 1993. It was a significant change in the volcano's behavior, a change that demanded attention. While the data from that swarm hasn't yet pointed to a definitive magma intrusion, it has put the entire region on a heightened state of alert. It was a powerful reminder that the giant is not deeply asleep, but merely dozing. This is where the clock watching begins. Geologists are loath to use the word overdue, but the numbers are undeniable. Over the last 10,000 years, Mount Shasta has erupted on average every 600 to 800 years. The last major magmatic event was 3,200 years ago. So, from a purely statistical standpoint, the mountain is within its historical window for activity. But the more pressing clock is the 200-year cycle of unrest. The last significant event, the boiling lahars down Mud Creek and Ash Creek, happened around 200 years ago. The 2025 swarm, arriving 2 centuries later, feels less like a coincidence and more like a historical echo. For decades, many textbooks and historical accounts cited a 1786 eruption of Shasta, supposedly witnessed by the French explorer Jean-François de Gallo, Comte de la Prusse, from his ship off the coast. Modern geology and radiocarbon dating have thoroughly debunked this claim. His ship was too far away, the angle was wrong, and the geological record shows no evidence of an eruption in that year. But the persistence of the myth reveals a deeper truth. For as long as people have looked at this mountain, they have seen it as a source of power and potential danger. They were not wrong. They were just off by a few decades. The real documented unrest happened in the 1820s. The clock started then. And so, we are left in a state of watchful waiting. The 5th most dangerous volcano in the United States sits astride a major transportation corridor in the nation's most populous state. It has a documented history of catastrophic collapse and fast-moving lahars. It is topped with ice and burning from within, and it has recently begun to shake. The work of scientists like Sarah Peake and Phil Dawson at Calvo is not about prediction. It is about diagnosis. They are listening to the mountain's heartbeat, taking its temperature, analyzing its breath. The network of sensors, seismometers, GPS stations, gas monitors is more sophisticated than it has ever been. But they are monitoring a force that operates on a geological, not human, timescale, a force that has built and torn itself down for 500,000 years. The uncomfortable truth is that even with all our technology, the first definitive sign of an eruption might be the eruption itself. Mount Shasta has not ended. Not yet. It sits silent, white, and magnificent against the blue California sky. But it is not sleeping. It is waiting. The swarm of 2025 was not the main event. It was a tremor, a throat clearing, a signal that after 2 centuries of quiet, the giant is stirring. And what it does when it fully awakens is a question that the 85 cubic miles of rock and magma beneath Hotlam Cone will answer on its own schedule. The science has issued its warning.